Hey guys, I hope this finds you well. Today I want to talk about a very important type of reaction, underbonding and reaction mechanism in organic molecules. So we want to look at chlorination and bromination of alkanes, what is at times known as the radical substitution reaction. A very candid example that we are going to look here is the example between the reaction of methane and chlorine. So we want to look at the reaction of methane and chlorine. That is a chlorination of methane. Remember, we can use any halogens. We can use the halogen, we can use bromine, and we can use chlorine. Now we are going to look at the reaction between chlorine and methane. We are going to show each and every step and the possible reaction mechanisms, So here, before we begin, we must start by looking at a basic definition of a term that we are meeting here, that is the radical. So what's a radical? So generally, a radical is just an atom or an ion that has unpaired valence electron, that atom or ion with unpaired valence electron. So let me just write it here. This is an atom or an ion with unpaired valence electron. So a radical is an atom or ion with unpaired valence electron. Example here of such a reaction, an example of this radical substitution reaction is an example or is a reaction between, let me focus on this, reaction between methane and chlorine. And generally, when you react a methane and chlorine, the substitution will happen, and one of the chlorine will replace one of the hydrogen from a methane, so that at the end of the day you will form a methyl chloride, and of course the hydrogen chloride. This methyl chloride is formed when the hydrogen has been substituted by one of the chlorine. So it's one of the substituted products, and then the hydrogen chloride will be formed between the reaction of the other remaining chlorine atom reacting with the substituted hydrogen. In this reaction, there are three important steps that we are going to look at. Three important steps or stages. These are called stages. So number one, we are going to look at the initiation stage. Then we will look at the propagation stage, and then lastly the termination stage. So just to begin, by the first step or stage, the initiation, the initiation. Remember, this reaction takes place at stages, but it happens very fast that at the end of the day you have your product at hand. So the initiation, what happens at the initiation stage? So at the initiation stage, the halogen used, that is chlorine, just to go back a bit, we know that this type of reaction is a halogenation, right? And it's the type of a substitution reaction, and therefore we require some element of heat. The delta here means heat, and then we require light. So delta in this case means high temperatures. So the reaction is done at high temperatures, delta, and the reaction is also done in the presence of light energy. And therefore, let's look at the initiation stage. So what happens in the initiation stage, as I was saying, is that the halogen chlorine radicals, the chlorine radicals are formed from the chlorine atom. So if you if you can be able to draw the Lewis structure of chlorine, this is the Lewis structure of chlorine. So what happens is that this bond here, this single bond here between chlorine atom, represent a pair of electron. This dash that you're seeing here represent a pair of electrons. The bond represent a pair of electrons. So therefore, what happens is that there is something known as the homolytic bond cleavage. The homolytic bond cleavage happen. So in homolytic bond cleavage, this is a type of cleavage in which two electrons in a cleaved covalent bond are divided equally. So two electrons in a cleaved covalent bonds, like in this case here, are divided equally between the two products. So therefore we are going to divide this pair of electron equally between the two products of chlorine. So therefore what happens is, when you draw that mechanism, we are going to draw the mechanism of that bond cleavage. So one electron goes to the first chlorine atom. So we represent the movement or the cleavage by half arrows, like that. So this is a homolytic bond cleavage, homolytic bond cleavage, homolytic bond cleavage. And then if that happens, that bond has been broken under the presence of high temperatures and light energy. So at the end of the day, we have in that system two radicals of chlorine atoms. Two radicals of chlorine atom. Remember, this one electron is represented there. So you can see that at least we are going to form two radicals at a time, because if this bond is broken, one of the electron move to the first chlorine and another electron move to the second chlorine. So you can realize that at the end of the day, we will have two of the chlorine radicals formed. So that is what happens at the initiation stage. And after the initiation stage, we move to the next stage, and that is the propagation stage. The propagation stage. So you can pause the video and do a follow-up and also try to synthesize the information at your level. And you are also free to like and comment. You can like and comment on the areas perhaps that you feel there's some addition that are necessary. Anyway, at the propagation stage, we have what we have at the propagation stage is the chlorine radical attacking the methane. How does the chlorine radical attack the methane? You remember that there are a lot of these radicals in that system. So therefore, these radicals attacks the hydrogen. It snatches the hydrogen. It subtracts the hydrogen from a methane. So what happens is, let me just draw my chlorine radical. The chlorine radical that we have formed, this chlorine radical that we have formed will subtract or will remove one hydrogen atom from a methane. This is just an open structure of methane with one hydrogen atom shown like that away from it. So what happens is that this unpaired electron in chlorine radical, right? This unpaired electron from chlorine radical subtract or removes the hydrogen. It removes the hydrogen from a methane. If that happens, then the bond here, the electron remaining in this bond here, moves to the next carbon. So at the end of the day, we will have the chlorine radical reacting with the hydrogen atom, and then one of the electron going to the immediate carbon, so that we will have another radical formed, the radical of methyl, the methyl radical formed. How does the methyl radical form? It forms when one of these electron moves to the next carbon. So this bond is broken, so it moves away, and then the electron is now shown as unpaired in this carbon here. So this is called a methyl radical. And another substance that is going to be formed is the one that will be formed from the reaction of chlorine and hydrogen that has been snatched, so that at the end of the day we have HCl. When chlorine react with hydrogen, we form hydrogen chloride, the hydrogen chloride. Then remember, in that system again there is more and more and more of the methyl radical. So what happens? The methyl radical formed has the ability, that methyl radical formed has the ability again to react with one of the chlorine from the chlorine molecule. Let me draw the Lewis structure of chlorine very fast. That is the Lewis structure of chlorine. So what happens is that again this radical of methyl reacts with the chlorine. So again there is a homolytic bond cleavage here. So one of that electron moves like that, and the remaining one moves to the immediate chlorine. So at the end of the day again we have the methyl chloride, because the methyl reacts with this chlorine to form the methyl chloride, or the methyl chloride. And remember, when this electron moves to this immediate chlorine, to the next chlorine, another chlorine radical will be formed. So plus chlorine radical, the chlorine radical is formed. Nice. So these are two important reactions that takes place at the propagation stage. Lastly, the termination stage. The termination stage is the stage now whereby any of the free radicals in the structure recombine or rejoins or reacts to form the final product. So what happens at the termination stage is that there is a combination of any two radicals, to form the final product. So let's see. So therefore, if there is combination of any two radicals, remember that in the system there are a lot of radicals. So the first radical that we have formed, or that we formed initially, remember, was the chlorine radical. Another radical was the methyl radical. So if this chlorine radical can form, so chlorine radical can react with another chlorine radical in that system to form chlorine gas. Then the methyl radical can again react with another methyl radical to form ethane, or the chlorine radical can also react with the methyl radical to form the methyl chloride. So there are three important final products that are going to be formed. The first one, we said that we are going to react the two chloride radicals. We are going to react the two chloride radicals because there are a lot of them in that structure. So what happens is that this unpaired electron reacts with the other unpaired electron, so that at the end of the day those two chlorine radicals joins together to form chlorine gas number 2. Another radical that can possibly react is the methyl radical. The two methyl radicals, radical is shown like with the unpaired electron. The two methyl radicals, again this unpaired electron joins to form an ethane. This is an ethane. Then those radicals again, the chlorine radical can possibly react. It can possibly react with the methyl radical. So if this happens, so in this stage the radicals are just reacting radical. If any radical is in the system, any radical in the system can react with the other. So chlorine radical, because it's there, can again react with the methyl radical. So at the end of the day we will have chlorine radical reacting with the methyl radical to form the methyl chloride as the final product. This is methyl chloride, the methyl chloride. So guys, this is what we've discussed today: the chlorination and bromination of alkanes. under the topic bonding and reaction mechanism in organic molecules. We began by looking at the definition of the word radical, and we said that a radical is an atom or ion with unpaired valence electron. We looked at some of the examples of the radical substitution reaction, and the reaction in specific that we looked at here was the reaction of methane and chlorine. Remember very importantly that this reaction was taking place at some condition, and the condition was high temperatures, and the condition was high temperature and light energy. Remember we said the reaction is taking place at different stages. The first stage was the initiation stage where the halogen homolytically get cleaved, and that is called homolytic bond cleavage. And we said, what is homolytic bond cleavage? Homolytic bond cleavage is the type of cleavage in which two electrons in a covalent structure or in a covalent bond are divided equally between the product. Like we can see that this single bond represent a pair of electrons which is divided equally between the two chlorine atoms. So this is a homolytic bond cleavage to form two radicals of chlorine. Then at propagation stage, this radical of chlorine formed, it can be able to attack, this chlorine can be able to attack the hydrogen or snatch the hydrogen from a methane, and the reaction mechanism is clearly shown and the stages are all here. Thank you guys for watching. Like and subscribe. Bye.